Okay, so we're going to talk about sequences. There are two different types of sequences, okay? There are arithmetic sequences, which we know are linear or additive, okay? They go up by a constant ROC basically because they have an additive or they subtract repeatedly or they add repeatedly, right? Then we have geometric sequences, which are like exponential functions, and they are multiplicative, and they have a non-constant ROC. It'll grow or get smaller over time. Okay, now each type of sequence, arithmetic and geometric, can be written two different ways. We have two ways of writing each of these. They're the same for both and they have the same name, they're just gonna look a little different. So for arithmetic, there's explicit and there is recursive. And the same thing is true for geometric. There is explicit and there is recursive. Recursive we learned about a while ago in Unit 2. These are the ones that are based on the previous term, and they're going to look the same no matter what type of function it is, whether it's geometric or arithmetic, doesn't matter, exponential, linear, doesn't matter. Okay, now explicit functions look a little bit different. The explicit form of an arithmetic sequence is going to look just like a linear function, y equals mx plus b basically. And the explicit form of a geometric sequence is going to look like an exponential function. It's going to be y equals a times b to the x. And what the difference is, explicit functions, they can give us actual values for any input, whereas explicit will give and for both of them, right, actual values. Whereas recursive, you need to know the term that came before to be able to write the next term. So if I want the 100th term for a recursive, I need to know the term before. Okay, so let's look at an example of a sequence, right? So let's say I have this sequence 1, 3, 5, 7, 9. So the first thing I'm gonna think to myself, if I'm gonna start writing functions for this, is what's the pattern, right? So I look and I annotate for the pattern, and I see plus 2, plus 2, plus 2, right? So I know already that this is an arithmetic sequence, right? Because it's additive. Okay? So now what I can think about is each one has its own term number, right? This is my first term. This is my second, my third, my fourth, and so on, right? So if we think of the term number as x, and then the actual value is our y. That's how we're gonna think about this stuff in sequences, okay? So first I wanna think about how can I write the recursive function. So we did that already. Recursive functions require two things. The first thing you need to write a recursive function is the first term. So here, I think to myself, what's the first term? Okay, so I go back here. My first term is 1. So I write f of 1 for first term equals 1. That's where I start. And then the second thing I need for a recursive function is the pattern. So here I know that that's plus 2, but I can't just write it that way. So this is always going to stay the same no matter what. We write f of x equals the term I want is the term before 1 less. So if I want the second term, I get the first term, and then I just add on the pattern. Okay? So that's how I would write this one's recursive function. Okay? Now let's try to write the explicit. So what's nice about writing the explicit is this is something you've already done before. We're just going to use y equals mx plus b. I know what m is because it's my pattern. M is my slope. M is plus 2. Now, the problem is I don't have a b value yet because this is my first term. And my b value is when x equals 0. So I go back to my function and I try to figure out if I went to the 0 term, what would it be? Well, I would subtract 2 here, minus 2, and I would get negative 1. So my b value is negative 1. And in this case, I can then write the explicit function as y equals 2x minus 1, or f of x equals 2x minus 1. Same thing either way. But I would be able to substitute any term number and get the right answer. So if I substitute in the third term, f of 3 would be 6 minus 1. I'd get 5. It works. Okay? So let's try another example of this because it's definitely a little bit weird. So if I have now a function that looks like 3, and I want to start with 3 actually. I want to start 2, 6, 18, 54, ... The very first thing I'm still going to do, always, is find my pattern. So, times 3, times 3. So I now already know that this function is geometric or exponential, right? Okay. So, same thing. Let's start with our recursive. And there are only 2 things we need for our recursive. The first thing we need is our first term. So f of 1 equals, and this is my first term. So f of 1 equals 2. And then, so I know part 1, first term. The next thing I need is my pattern, right? So all I do is I write the same thing from last time. F of n equals f of n minus 1. We could use n, we can use x, it does not matter, right? It's just a variable. And then I add on the pattern, which in this case is times 3. So here, I included my first term, and I included my pattern. This is my entire recursive function. I'm done, right? So I can't do much with this unless I know all the terms and I want to list them all out. So then we can move on to how to write the explicit function. Now this is going to be different because now we're using an exponential function. So our general form is going to be y equals a times b to the x. So in this case, we need to find, same thing, y-intercept and our growth factor. Well, I already know my growth factor, right? My growth factor is easy because they gave it to me. This is my b value. So I already know b here is going to be equal to 3 because we're multiplying by 3 each time. But for my y-intercept, I need to do the same thing. I need to go backwards to find the 0 term. So we're going to divide by 3. And when I divide by 3, I get 2 over 3. I do not want you to turn that into a decimal. I just want you to leave it here. This would be our initial value. So our a value here is 2 over 3. And all I need to do now to write the explicit form is f of x, or y, equals, I start with a, we have 2 over 3, times, my b value is 3, to the x power. And that is our explicit form. And just for practice one more time, if you want it, at this point you can shut off the video if you want. We're going to do one more. 4, 7, 10, 13. Okay. First step, always find my pattern. Well, my pattern is plus 3, plus 3, plus 3. So I know that this is arithmetic because it's adding. So we do our recursive formula first, and we start first term, f of 1 equals, this is my first term, it's 4. And then I just do the same thing as always, f of x equals f of x minus 1. plus 3. And we can box it because we have the pattern and the first term. Final one is the explicit formula for this one. And the explicit formula for this one, we go back to y equals mx plus b because it's linear. I know m already is my plus 3. And I need my b value, so I'm going to go backwards minus 3, and I find that my b value is 1. For my initial value, we write our equation. Y equals 3x plus 1. Box our answer, and we'll be done. My suggestion is that you bring these notes with you to class tomorrow, and it will help make things a lot easier, okay?